Hello, everyone. Thanks for joining us today, and welcome to OpenInfra Live, the Open Infrastructure Foundation's weekly hour-long show featuring production case studies, open source demos, industry conversations, and the latest updates from the global open infrastructure community, streaming every Thursday at 14 UTC to YouTube, LinkedIn, and Facebook. My name is Kendall Nelson, and I'll be your host today. Since we're streaming live, we will be answering questions throughout the show. Please feel free to drop questions that you have for today's guests into the comments section of wherever you're watching this stream. And we'll get through as many as we can throughout the show and try to save a little bit of time at the end as well for more. We have a jam-packed episode today, so let's go ahead and get started. Kicking off today, we'll have Tom Barron from Red Hat, who is going to give us an overview of Ceph before rolling into how it fits with OpenStack via Cinder and Manila, and also touch on Kubernetes as well. Take it away, Tom.
Hi, Kendall. Thank you. Next slide, please. I'm going to talk very quickly about Ceph and OpenStack and how they integrate to set the stage for what follows. OpenStack, as everybody I'm sure knows, is an infrastructure as a service cloud technology. And for storage infrastructure as a service, we have object, block, and file storage offered by Swift, Cinder, and Manila. Now, the important thing about these is these are self-service, of course, and that they are integrated with Keystone to provide tenant separation. So users belonging to separate Keystone projects get their own virtualized view of storage and basically do not step on one another, cannot impinge on each other in terms of security and so on. They also cannot mess with the cloud resources directly, so they're protected. Now, this is most obviously, perhaps, relevant to people who run OpenStack as public clouds, but it's not just for public clouds. Large enterprises run tenant separation for departments and so on within their organizations. Similarly, for government and public sector, we see telcos who have regulatory requirements to run separate applications and separate tenants and so on. So this multi-tenancy and Keystone integration and self-service storage infrastructure are the themes on this slide. Next slide, please. Ceph is a natural fit here because Ceph technologies offer object, block, and file storage, all based on RADOS technology. So a common low-level object store technology is used via libRados by the RGW RADOS gateway, which can stand in for Swift and offer an S3 or Swift compatible API and integrate into OpenStack that way. By the RADOS block device, RBD, which offers virtual block devices, which can be a back end for Cinder, and by CephFS, which offers a distributed POSIX-like file system, and which can be a back end either by itself or gatewayed to NFS for the Manila service. Now, let's go to the next slide. RBD has been consistently ranked as the most deployed backend for Cinder, and CephFS has been consistently ranked as the most deployed backend for Manila. Now, with our distribution, I work at Red Hat, we typically see RADOS Gateway also deployed as a stand-in for Swift when you're using it for Cinder and Manila, and I'll mention it's typically used to back Nova ephemeral storage and glance images as well. Next slide, please. We could, as I've emphasized, but let me take a moment though to talk about why it's popular. And we can talk about this more in discussion, but clearly there's an economic advantage in being able to deploy Ceph on commodity hardware and to be able to handle all three services from the same hardware using the same set of software, rather than having to purchase separate appliances, potentially from separate vendors for each service, rather than having to train operators in separate skill sets to manage the storage technologies behind them. And nowadays, I'll mention there have been such improvements in Ceph in terms of the management of it. There's a common dashboard, common pane of glass on all of this, so it's easier and easier to manage. When you combine Ceph with OpenStack, you get this multi-tenant separation with Ceph. Okay, I'm not saying you can't do it with Ceph without OpenStack, but you get it integrated with the rest of your identity system and so on that you're using for OpenStack. You end up with a cloud infrastructure where it's more like a public cloud like AWS or GCP than say vSphere or something where it's just more or less just a virtualization platform where you have to have special privileges, for example, just to bring up the equivalent of a compute instance, a guest VM. The other thing I quickly say about the popularity and fit here, pardon me for not going a strict connection here, is that, of course, Ceph is open source. Now, what does that mean? So we have open source OpenStack and open source Ceph. You avoid vendor lock-in. You don't pay somebody for a license to run something that you cannot even inspect the inside of. It's like you don't. So people that don't like to get software or a hardware solution where they have to pay for a license is like buying a car that you can open the hood on and hire a mechanic and work on it, or you can look at it yourself. And there's a vibrant Ceph community. So if you have a bug, you can see who else has the bug. You can talk about it. You can affect bug prioritization. You can affect the new feature development. You can participate in the conversation. So it's a natural fit with OpenStack in that way. Thank you. And sorry, I just wanted to dwell on that point for a moment. We can go to the next slide. Now we're going to talk about another big open source project, Kubernetes, running on top of OpenStack with Ceph is the next topic here. In the popular press, you often see OpenStack and Kubernetes posed as exclusive or proposition. When are people going to move from OpenStack to Kubernetes? Should you use one or the other? The point of view we have here is that they're complementary rather than exclusive. Okay, what Kubernetes brings to the table is a simplified orchestration and scaling of applications with a little bit of YAML or with distributions that build on top of it, like OpenShift, even just point and click. You can deploy applications very simply. You can scale them out. You can combine them and run them in the cloud, meaning not just on a single node, but scaling out over the whole cloud. For example, with our distribution for IPI, installer provisioned infrastructure, a regular OpenStack user, a member of a project, nobody special, can effectively press a single button and it provisions all the OpenStack compute instances they need for their OpenShift nodes. It builds the storage classes they need to do dynamic provisioning of storage for persistent volumes with Sender and Manila. And it sets up all the networking, ingresses, load balancers, et cetera. So bottom line here is users don't have to be system administrators to run applications on top of OpenStack if they're running on top of Kubernetes on top of OpenStack. Now, in the early days of Kubernetes, people thought it was going to be stateless, but everybody knows now that you need volumes. And many of the popular applications that are often shown are things like, WordPress. you need state and you need persistent volumes. And there are a couple of important concepts in here that people should be aware of. One is volume mode. Traditionally, Kubernetes has worked with what's called file system volume mode. It gives you a persistent volume at a mount path, like var www, something like that, as opposed to at a device path, like dev VDB. Okay. Nowadays, you can also run raw block mode, volume mode, and you can do the latter. But what that meant is that normally with even with a block device provider like Sender, you would get, it would automate for you the job of, I have a raw block device, I'm going to attach it, I'm going to format it, I'm going to build a file system on it, and now I expose this path, var www or whatever, to an application. That was all done for you with file system. Okay, now this is, you can now do a block and you just get dev VDB or whatever if you want. Now, most of the applications that people run, if you look at, for example, at the OpenShift catalog of applications, are assuming file system. So Manila gets an increasing fit in Kubernetes relative to what it had in OpenStack, I will assert, because it's so easy to deploy applications across multiple nodes. So in OpenStack, that's going to mean you're running on multiple Kubernetes worker nodes, which are running on multiple compute instances or VMs, Nova instances, conceivably bare metal in the future, in OpenStack. Having a file system and a shared file system that can span these nodes is handy and useful, and it's going to be something people do more and more. This pertains to something called access modes in Kubernetes, where they talk about read once many, read write once, and read write many. I'll focus on the second two with respect to Sender and Manila, because they are complementary rather than redundant. So Manila can do read write many in addition to the other modes in file system volume mode, but it doesn't support raw block volume mode. Sender does read once many and read write once in file system volume mode, but not safely read write many. We can talk about that at length if people want to, but you can potentially corrupt your file system, and in any case, you get inconsistent contents across different nodes because you use XFS or by default ext4 node local file systems with Kubernetes, not a clustered file system. So Sender RWX is for raw block volume mode, and you can do that there. If you have multi-attach and Sender, you can do RWX with raw block volume mode. And that's useful for certain databases that work with offsets rather than file paths. It's useful for ISOs and boot volumes, stuff like that. Here, I'm going to quickly point to a picture of I'm showing two OpenShift clusters with Manila in this case running on top of OpenStack. And the details aren't that important at the moment. But the point is that you got a Ceph public network. We're sharing via Ganesha in this case to provide NFS service to these separate OpenShift clusters, which belong to regular users. There could be hundreds of these on the OpenStack cloud, all unrelated, all ships in the night to each other. Just like if I've got OpenShift because of the Red Hat package, Kubernetes. just like if somebody goes to Amazon or GCP, pays their credit card and gets on, they can run a Kubernetes cluster on top of it, deploy it themselves, and then another person can deploy it, and they don't touch each other. And we can kind of thing in this. This is the picture. This is the vision of hundreds of clusters running on Kubernetes clusters running on a single OpenStack cluster. People worry sometimes that because of all the service layers involved in Manila and Sender and provisioning, that it would not work at, quote, container scale. I kind of laughed at container scale because if you run containers inside OpenStack on VMs, you have your VM scale is actually a little bigger than your container scale, even if you do nothing but run Kubernetes. But what's meant here is that it's so easy to orchestrate the provisioning of persistent volumes and of pods and containers with Kubernetes across the cloud that you can get rapid bursts of creation needs. So we have been studying this with, in this case, the entry sender driver, the newer container storage interface sender driver, and the Manila container storage interface driver. I'm saying driver from OpenStack, but provisioner in Kubernetes on, in this case it's on OpenShift on OpenStack. And so far we're seeing a nice flat growth pattern, which is what you don't want to see is a knee in the curve. Where suddenly there's an inflection point and you can no longer handle increased load. So what we're doing in these tests basically is creating a single new PVC, PV via PVC, persistent volume, for each pod and scaling up the number of pods. The pods never come up to running space if the provisioning is not successful. You stack up a whole bunch of requests right after one another. They're async, so there's a lot of parallelism. And we're able to drive, in this case, 3 worker nodes can handle 250 pods per worker node. There's some pods already running, so we're running it up to about 650 pods, and it all stays pretty flat. And we see that the newer container storage interface provisioners are doing a little better than the entries, which is good. So I could talk about this stuff all day. I'm already running over time. Sorry about that. Let's hand it back to Kendall. And thank you for your time, folks. You know where to find me.
Yeah, that was a ton of really awesome, helpful information, Tom. It's awesome to see all the different open source communities working together. It's not just OpenStack, it's also Ceph and Kubernetes together. Do you know if there are any like easy ways into the like connection points in those communities, Tom?
Well, I know that the OpenStack technical committee has been working with the Kubernetes. There's a liaison who works with them. I forget her name, and
might be me.
Kendall Nelson. So the communities are working together and talking about how to integrate. Obviously, Kubernetes wants to work on every cloud, not just OpenStack. So we have special interest in that and in getting the story out that the two are complementary.
Definitely.
With Ceph, you're going to hear a whole lot of Ceph integration stuff in the next presentation, I think. So it'll almost speak for itself on that.
Yeah, awesome. Thank you very much. So it's an excellent lead in to our next presenters, Francesco Pantano and John Fulton, also from Red Hat, to talk about the TripleO integration with Ceph.
Hi, yeah. So I'm John Fulton. I work at Red Hat on OpenStack Ceph integration. Let's talk about why we would focus on this. So Tom already covered that. He already explained that Ceph is the most popular storage backend for OpenStack for both file and block storage through Manila and Cinder. There's a reference to that in the OpenStack analytics survey. It's been the most popular this year in 21 and in previous years. There's also a interest in hyper-converged infrastructure, or HCI for short. And by that, I mean running storage and compute on the same server. So given all those interests, we want to make it easy for people to be able to have these things with TripleO. So TripleO is our preferred deployment platform for deploying OpenStack, but it can also deploy Ceph. So to make Ceph as easily accessible to people, we just add a Ceph option to TripleO. So, oh, I'm deploying OpenStack. Yeah, let me get Ceph with that too. Just add in Ceph, as easy as adding some additional YAML files when you do your deployment. We also have the option to for the OpenStack that is deployed by TripleO to use an existing Ceph cluster. So if you have an existing Ceph cluster and some properties about it, like its IP and some CephX keys and pools, you can put those in a YAML file and also pass it to TripleO, so that when the OpenStack is deployed by TripleO, it's ready to go, ready to use block file and object storage from that Ceph cluster. And then we also test both Ceph and OpenStack together, like it's just one system, as if Ceph were a part of OpenStack, though it is its own separate project. So to give you some context, an overview of how a TripleO deployment works, it will, TripleO can do everything for you. So you can give it IPMI information about your hardware, and it will then use Ironic to provision the hardware. It will configure the network. It can then deploy Ceph and then deploy OpenStack. So it can do the whole thing for you. You can have a deployment definition file or files and a couple of YAML files describing the end state of your system, and TripleO will make it so. So for Ceph deployment, Ceph Ansible is a pretty popular tool for deploying Ceph, but with the Ceph Octopus release, a new tool called Ceph ADM was introduced. On the TripleO Wallaby release, we switched from triggering Ceph Ansible to triggering Ceph ADM instead. And in this change, it presented an opportunity to improve the user interface. So some of the usability enhancements we did was we now have a faster client configuration. So we no longer use Ceph Ansible's client role. We wrote our own very light Ansible role in TripleO Ansible that focuses on getting the conf file and the keys out quickly to your OpenStack clients. We also use Ceph's natives tools as quickly as possible. So we still have our deployment definition, which came from our deployed metal and our composable roles. But then we have a new Ansible module that we just feed into TripleO, and it gets translated into a Ceph spec. And I'll get more into that. But we generate the spec for you, and then you're free to apply it. But if there's issues with it, you can modify the spec, and you can drop right into the Ceph ADM shell during deployment. We wanted you to be able to do that as quickly as possible. And all day two operations are done directly with Ceph's tools, not with TripleO, on the Ceph cluster itself. So for scale up and scale down, you still use TripleO to add new nodes, but once it adds the hardware, you can use Ceph ADM to add your OSTs, for example, if you were adding more storage. And we also have more isolation, so you can actually deploy Ceph before you deploy OpenStack, even if you're using a hyper-converged deployment, meaning even if they co-locate the same hardware. I call this the deployed Ceph feature. So the idea with deployed Ceph was strategic decoupling, based on user feedback. So there were things we did want to do. We wanted to do provision the hardware and network, do create the Ansible inventory for me, and do put the right Ceph service in the right place without my needing to know the details, which we cover in our composable role defaults, though you're free to change them, but you don't have to worry about them if you don't want to. Of course, configure OpenStack to talk to Ceph. And let me use Ceph's native tools as soon as possible, but don't make it harder to debug the Ceph deployment, and don't require all Ceph changes to be done in TripleO. So those are some changes coming. So to put that back in the other picture, the deployed Ceph feature, we introduced some new commands so that it stays well integrated with TripleO and configures things so they'll work well together. It lets you focus on number 3 separately. After you've done 1 and 2, you can focus on 3 without having to worry about 4, even if you're doing hyper-converged deployments also. So I have a link there to the documentation on how to use that. So it's called the deployed Ceph feature, because when you're deploying OpenStack, Ceph is already deployed, even if it's internal or hyper-converged. So I'm going to talk a little bit more about how this works. So the Ceph ADM tool, it's a nice little tool. The way it works is it bootstraps a tiny Ceph cluster for you, and then you just scale. So to bootstrap the first node, you just run one command, Ceph ADM bootstrap, and you specify your monitor IP. And then you have a working Ceph monitor and a Ceph manager. And then assuming you've distributed your SSH key pair for other hosts, which will be a part of your Ceph cluster, it can then add those other hosts if they are listed in a spec file. So I could do Ceph orc apply and then reference a spec file, another YAML file. So those 3 things happen. When we wrote Ansible in TripleO, so it does this for you when you use the new OpenStack client with the TripleO client plugin and the tools we wrote for Ceph. So it takes care of that for you. It knows the IP because it set up the network. It distributes the SSH key pairs, and it generates the spec based on your existing deployment definition. So if you're used to, if you're using TripleO and you're used to maintaining things in the existing YAML files from the previous versions, those still work. We do a translation, so we have backwards compatibility, but then it's in a new spec file in the new format, which you can look at. So we apply all this for you. So Francesco is going to go into some more detail on the interface.
Yeah, thank you, John, for the great presentation. So at this point, you can have deployed Ceph first, or you can just describe your cluster and push the button. This work is available from Wallaby, and we are basically maintaining the same TripleO heat templates interfaces, passing the new environment file and the other overrides that where your Ceph cluster is described. And then after the interface is provided, there are some TripleO Ansible rows and modules that do basically 4 steps. They prepare the context, they create the user, SSH keys are created and distributed all over the overcloud, and then instead of triggering Ceph Ansible, which is the old tool, we trigger Ceph ADM, the new Ceph ADM playbook, and at the end of this process, there is the cloud configuration via the new quick TripleO Ansible role. The thing I want to highlight here is that now with this from Wallaby, RGW is deployed by default, which is a big change from the past, unless you want to exclude it from the first deploy and deploy just the first minimal cluster made by monitors, managers, and OSDs. The other thing is that the TripleO templates interface is backward compatible, so we're maintaining options that are defined by overheaders. So you can customize crash rules and create different device classes according to the Ceph cluster and the hardware where it is deployed. You can customize Ceph pools, and they can be tied to these crash rules. So you can just define a different crash map with a different hierarchy according to device classes that can be faster or not. And then you have Ceph config overrides, which means that at deployment time, you can pass a couple of information to the Ceph that are assimilated by the Ceph.conf so that they can be translated into manager options. Okay. The other two things I want to highlight at this point is that TripleO integration is not just deploying the first minimal cluster and then adding some daemons, but we have also TLS everywhere and high availability. These are two key points for TripleO deployments, because having services with TLS and in high availability way, it's one of the key points for TripleO. So Ceph is going to provide at this point native HA for NFS, for the dashboard, for RGW. You can define an ingress like the Kubernetes way, let's say, and everything can be deployed behind HA proxy and keep alive D for the VIPs. But at the moment, we have some challenges we need to solve on the TripleO level, which is basically the key insert generation and request. At that point, we will have multiple HA proxy instances, and the collocation of Peacemaker and Keep Alive D is problematic. So at this point, TripleO do two steps. The first one is generating keys and certs using a new Ansible role, and then execute this role against the services that should go under TLS. And then at step two, HA proxy is configured at OpenStack level, and Peacemaker is used for virtual IPs. Then this information are passed to Ceph ADM, which is able to deploy and assimilate the certificates that are generated on the previous step. There is also a link with an example of how to do that. As John said before, we have a spec where we can paste some information, and RGW is just an example of that. Next slide. Okay, this is one of the other challenges we're trying to solve within the TripleO project, which is upgrades. When you upgrade your OpenStack environment, we can do that. We can do the same for Ceph, and we used to do that using Ceph Ansible, which was the official deployment tool and the most popular one. And it happened in different phases. When we get from Luminous to Nautilus, we had the rolling update playbook and file store to BlueStore conversion, which was a nice feature. From Nautilus to Pacific, which is the target here, we still have the same rolling update playbook executed by Ceph Ansible, and then we need to make the cluster being adopted by the new backend, the Ceph ADM daemon, which means that at the end of this process, all the variables that were defined, the status of the cluster that was maintained in TripleO is now maintained in Ceph ADM, which is a really big change. And from Pacific onwards, the upgrade path is provided by the orchestrator, and it's an asynchronous process. So this means that you can start your upgrade defining the Ceph version that you want. You can monitor the upgrade or even cancel the upgrade, which means we have a rollback path, and this means that more work can be done at the TripleO side. And yeah, let's bring on what's next in TripleO. As I said, the upgrade is one of the biggest chapter in terms of integration, and it will be an asynchronous process, so it will be managed by the orchestrator. So the idea is to decouple more from TripleO and make the two processes separated, so that operators can work on starting the upgrade, monitor the upgrade, roll back the upgrade if any problems occur in the Ceph cluster, and deployed Ceph that was mentioned by John. At the moment, is just isolating the Ceph deployment in a different phase than the overcloud deployment, and it's just a minimal cluster made by monitors, managers, and OSDs. The idea is to add more services this step and reducing the time spent during the overcloud deployment phase, where the Ceph cluster is described, and you can push the button and TripleO make it so. So yeah, thank you.
Awesome.
That's it.
Yeah, I had no idea that Ceph was so integrated with TripleO. But so you kind of touched on this a little bit, but with Xena coming out next week and the start of like yoga development now, are there plans for continued improvements? You touched on that a little bit, but for integration with Ceph and TripleO, like actively being developed and discussed right now.
Yeah, definitely. There are a lot of topics we are going to discuss. For instance, the Manila team, we are collaborating with Manila team to support an FS managed by Ceph ADM, which is a big topic because we need to sort out some backwards compatibility and move forward with new features. So this is something we are going to discuss at the PTG for sure.
Awesome. Cool. Well, I'll talk a little bit about the PTG closer to the end of the show, but we did have one question from the audience that maybe you both can talk about a little bit. How do you divide resources between Ceph and OpenStack in hyper convergence? What rules do you use for it?
Yeah, we definitely have that in TripleO. The more you know about your workload, the better you can isolate the resources. So the general philosophy is to split it on the NUMA node in a hyper-converged deployment so that you have one NUMA node for your Ceph deployment. On average, you want to allow about 5 gigabytes per OSD. You might have multiple OSDs per device, because if you have faster and faster OSDs, you'll get, like if you're using NVMEs, you might want to make 4 OSDs on them to get more performance out of them, and therefore you would multiply that. It's a big counting game, right? So a certain amount of CPUs, like 1 or 2 CPUs per OSD, and then 5 gig of RAM per OSD, and then you have a certain amount of room left over for your Nova compute workload. And then depending on the needs of that Nova compute workload, you can also schedule it with pinning. So we have done testing where we're doing network function virtualization on hyperconverged nodes, able to so that the Ceph processes don't preempt that low latency workload which we need. So it's definitely possible. It's just a matter of getting the system tuning right. So we have that documented, and we have flags in TripleO so that you can deploy it with that network, that isolation out of the gate.
Awesome. Hopefully we can get some links to those resources and share them after the episode. Thank you very much. So now that we have a basic understanding of like Ceph and how it fits into OpenStack, both integration with Manila and Cinder, but also with TripleO, let's dive into some of the use cases and like real world companies running these things together. So first we have Harrouin from Societe Generale to talk about their deployment of OpenStack and Ceph together. Oh, I think you're muted.
You are correct. That's better.
Awesome.
Thank you, Kendall. So hello, I'm Harrouin from Societe Generale, and we're going to explain about our experience with OpenStack and Ceph that we had so far. So just a quick word about Societe Generale. So Societe Generale is one of Europe's leading financial service group. It has been on the economy for about 150 years so far. So it supports 30 million clients every day with 133,000 staff in 61 countries. And like you can see on the screen, we have 127 data centers worldwide, mainly in Europe, of course, because it's where Societe Generale starts, but it's expanded in US, Asia, and Africa. So let's talk about the origin of OpenStack and where it comes from. So the platform of OpenStack in Societe Generale started in 2018. It was first in Queen's release. So at the beginning, we only had 2 regions available, one in Paris and one in North, both in France, of course. We had just 20 hypervisor, and we used Cola and Cola Ansible to deploy it because it was very easy to use, and also it's easy to integrate Ceph with Cola Ansible. So it was because we wanted, of course, Ceph as a backend it was a good tool to use. And today, so it has been like 3 years, almost exactly 3 years, and so we have now 4 regions. So we have still Paris and North in France, and we have also Hong Kong in Asia, and in US we are in New York. And now we have also multiple availability zones. So in Paris we have 2 availability zones, 2 in Hong Kong and 2 in US. And Ceph cluster, we have 1 Ceph cluster per availability zone. So it means that today we have a total of 7 Ceph cluster. We have a total worldwide of 350 hypervisors, and currently there is around 12,000 running VM, and that represent around 43,000 vCPU consumed and 210 terabyte of RAM consumed. On Ceph side, so we start on Ceph. We used, of course, Ceph Ansible. At that time, it was the more useful tool. Ceph ADM didn't exist, so it was the best tool to use. We was in Mimic release, of course, and one particularity that we have in Societe Generale, it's like we split the organization per services. And our team was more focused about the compute side. And so for the backend, so we use Ceph only for instances and images, so only for disk, VM disk and glance images. And about the volume offer, because we decided that we are more focused on the compute side, there is a team dedicated to the volume services. And so they maintain on their side Cinder. And for the backend, they decided to use pure storage instead of Ceph. The reason is because they was more confident to use this product and to have some editor behind to have some backup, and also provide a built-in solution with all the architecture and the hardware. And we use also cache tiering feature. The reason why we use the cache tiering feature is because when we started in 2018, so we had hyper-converged infrastructures, and the hardware that we ordered at that time was similar to an hardware that we was used to order for another private cloud that is running on VMware on Societe Generale. And so on this hardware, we had some SSD and HDD. And at start, when we start to configure Ceph, the crash rule, that we configure was not specified on the class of the SSD, the disk, but on all the disks at the same time. So it's mean that the images and the instances were running on HSD and SSD at the same time. So that's mean that the performance was kind of random, depending of the luck that you have if your image or VM was popped on the PG that was only on SSD or HDD. So that wasn't really a perfect solution. So to be certain that all the clients have the same performance and to use more efficiencies of SSD, we decided to use the cache tiering feature. And the balancer module, I think everybody that have Ceph in production knows that by default, the balance of data between the OSD are not very perfect. And so the balancer is here to help you to be certain that the usage of your disk is kind of optimized. We had some issue with the balancer module. Like, for example, when we added some new host, sometime they wasn't being integrated by the balancer, or the balancer didn't take them in account and didn't try to rebalance data. So we had to sometime work on the crash map directly to edit some stuff. But it's going better because recently we previously used the Chrompat method and we moved to UpMap, and it's a lot better right now. And quick word about the scale of Ceph. So we have today 60 hypervisors worldwide that are running Ceph with 650 USD. And worldwide, so the terabytes used, I didn't put the number of objects, but it's pretty high also, of course. It's like 500 terabytes used on 1,000 terabyte available. It depends on the region, of course. Some regions are more used than others, but we try to, of course, be able always have some free space because it's running production, and it's always better to have some free spare. And finally, we also use Prometheus and Grafana for monitoring purpose. So what's next? So the first stuff that we want to do, of course, it's upgrade Ceph. Like I said, we start in Mimic in 2018, and unfortunately, we still are in Mimic release. We had some issue in the past because of that. So that's another reason why, also, of course, we want to migrate to Pacific. And of course, the other obvious reason is because it's more stable, performance has improved, and there is new feature very useful like Ceph ADM. Also, we want to get rid of cache tiering because it's adding a lot of complexity on the Ceph side, and it's not a feature that is well used worldwide. So in case of issue or question or anything, it's more complicated to find people that have the experience with the tool. And because Ceph is not the main part of what we work on the team, we want to have the simplest Ceph infrastructure as we can. So that's another one we want to get rid of that. And of course, we want to deprecate the hyper-convergence model for biggest region. For example, in Paris, that is the biggest region so far, we have more than, on one cluster, we have around 160 OSD that are split on 16 hosts. And because they are running at the same time OpenStack resource plane and Ceph resource, there is some conflict time to time, or when you need to put the host in maintenance to make some hardware modification or upgrade or anything. It's more complicated because you need to take care of migrating the VM, say remove the host from the scheduler, and then on Ceph side, maybe put some flag, for example, on Ceph to not replicate the data because you, for example, just want to reboot the host. So it's adding some complexity also. And so that's why we, for example, in Paris, the biggest region, we order a lot of new hardware, and it will allow us to move to a specific hypervisor that will only host Ceph with only SSD disk. So we want to, at some point, have only SSD on Ceph running. It will be a lot more simple to manage, and we will have less pool and less complexity on the crash map. And the last part is containerized Ceph on Docker host. So when we used Ansible to deploy OpenStack, we, of course, decided to containerize components. But for Ceph, we didn't take that choice. So right now, for example, Ceph is running on the bare metal itself. So because we want to migrate to new infrastructure, it could be nice to, at the same time, of course, containerize Ceph, because we are more used to work with container on the team, and for all perspective, it makes easier to deploy and run Ceph. I think using containers are just running it on bare metal itself. And that's conclude my presentation of Societe Generale.
Thank you. That was very, very interesting learning about all the details of implementation. I'm glad you touched on upgrades and stuff as well. So if you're planning on upgrading from Mimic to Pacific for Ceph, what release are you currently running for OpenStack? Is it Usuri, like your one slide?
Yeah, okay. We are currently in Usuri, and we plan to migrate to Xena maybe at the start of next week.
Oh,
and
awesome.
For Ceph, so you can't upgrade directly to Pacific. So we're gonna need to run multiple upgrades.
Okay.
And at the moment, we only perform minor upgrades on Mimic. So we never did a big major upgrade. So we still need stuff to learn and to read, but it's in progress. And I think it should be, the minor upgrade was quite easy to run. So I expect the others to be as easy as this one.
Good luck with all of that. Upgrades, I know, are always a fun topic to discuss, especially running a cloud at the size that your company does. Yeah, so thank you for all the information. We'll keep on moving here. Our next deployment is at VEXXHOST, and here to talk about it today we have Mohammed Naser.
Thanks, Kendall. Hi, everyone. So I think so far it's been a really awesome show, and there's been a lot of different perspectives, but I want to start by sharing our perspective and give it a little intro about us. So my name is Mohammed. I'm the CEO at VEXXHOST. I'm also a board member on the what is now the OpenInfra Foundation. That probably should fix that slide. And I'm also on the OpenStack technical committee. I used to be the project team lead for Puppet OpenStack and OpenStack Ansible. Currently working a lot hands-on with OpenStack Helm. Here's my Twitter for the Twitter folks. And yeah, so I wanted to talk about our story and experience with Ceph and OpenStack. And we do a little bit of Kubernetes as well. So what we do is currently all of our deployments are running Octopus at this point. We try to do as well of a job as we can to keep up with updates. And actually we have some Pacific deployments, but Octopus is, I'd say, the oldest deployments in our cluster. You know, staying up to date in Ceph is really something that we find is really good, because a lot of times you think things are going stable, then you run into some weird issue that is only solved in a future release. And so you're having to do an upgrade in the time where you really don't want to do an upgrade. So in my experience with Ceph, the stability of the software is really, really good. So your risks of having any issues while doing an upgrade are probably far less likely than some weird problem that shows up down the line. So what we use it for, so our OpenStack control plane for all of our deployments runs inside Kubernetes. And so we actually use the Ceph CSI, the Ceph RBD CSI that's maintained by the community to provision RBD volumes that are attached as Ceph persistent volumes to run our OpenStack control plane for things like RabbitMQ state and MariaDB storage. We also use RBD for virtual machines for block storage. So obviously for Cinder, anytime you create a volume in our public clouds or any private clouds that we deploy for customers, it's actually a Ceph volume underlying there. And for a few clouds, we offer the Swift and S3 compatible API using Rados Gateway. So that's something that's quite popular, and especially for a private cloud environment, having one storage solution that can encompass both of your block and object storage needs, as well as file share storage needs, is really nice and useful. So over the years of us operating Ceph, which is probably entering maybe 10 years or so, we've gathered a few things that I wanted to share on what to do and what not to do. So I'll start it off with using the straightforward code base. And what I mean by saying the straightforward code base is there's a lot of little features and interesting things that are kind of maybe recently introduced or recently added, or things that you could possibly do but are not usually like as well documented. Those are usually the places where you might start running into edge cases, and that's when you might be in a really bad spot, because now you're working with something that not a lot of people have had experience with, or perhaps the code base is not as rigorously tested as possible. When I say like straightforward code base, I mean, you know, simple pools, maybe different device classes that you're using, maybe different, you know, sticking to 3 replicas, 3 monitors, don't put OSDs on the monitor nodes, like whatever is kind of the de facto. If you go with that, you're probably going to have a really good experience and you'll be able to sleep at night well. And when I also mention work carefully, it's really important to kind of realize that it's like a large distributed system. And so every change that you make could have a lot of different effects across the entire system. So being very mindful in every change that you do, because you could cause potentially problems for the cluster. I remember This is a really, really, really old story, but I remember the folks at DreamHost, where Ceph first started, had botched the crush map and ended up moving all of the data to like the first rack of their entire system, and then having to rebalance everything again when they made, I think, a crush rule typo or something like that. It was a long time ago. I really advise to using 3 replicas at least. 2 replicas is very tempting, especially with how we feel NVMEs and SSDs are reliable. But the biggest problem with running less than 3 replicas is if you get unlucky in how power is shut down or something like that, Ceph is going to have a hard time figuring out which one is the authoritative, because it's impossible to have quorum. It can't have 2 replicas that are agreeing with each other and one that's not, so that it could decide that that's the right thing. And sadly, the internet is full of horror stories of folks that were running 2 replicas that ran into problems when they had a crash or something. And also, it really kind of hinders you a little bit in your maintenances and any issues that you have. I mentioned staying up to date. So, going back to that, at least if you're too worried about doing major upgrades, at least stick to minor upgrades. Ceph is relatively painless to upgrade. As much as it's a stateful storage service, its services are relatively stateless. So it's really just a package update, restart of a service sort of thing. And if you've got the rest of your infrastructure well designed, you should be pretty easy to do these rolling restarts. So these are the things that I want to ask people to be careful about. Cache tiering, it's one of those things that looks great on paper, but you really need to understand your workload. You really need to understand what are the consequences of using cache tiering. And it's not a straightforward code base. It's not something that people commonly use. So you might run into weird issues that can really rattle up your deployment and kind of get you worried. Erasure coding is the same thing. It's also, I feel like it's not as commonly used. I've always been worried about it because we've seen some edge cases, just reading some of the community experience. And what I find is, hardware like storage has become pretty cheap, relatively speaking. And when you're running Ceph, which is an open source toolkit, you're saving a lot on appliances and software licenses and all that other stuff, which you could invest into hardware and get some reliable hardware and just go for normal replication. Careful about hyper-converge. So hyper-converge is something that we do offer and we've ran in the past, but it really is a very tricky thing to continue to run and do it right. You would get things like, what if down the line you don't need more compute resources, but you need more storage resources, but you've only allocated 40 or 50 or 60 gigs of memory on that compute node for Ceph. Well, do you add more disks? But if you add more disks, you're going to start eating up in some of your compute capacity. And so you starting to have that kind of like linking of compute capacity and storage capacity, as well as, the noisy neighbor issue that we all know about. It's not, and then it's even worse when you have Ceph OSDs that are running. So it's quite tricky. You've got things like, contention for network, contention for memory, contention for CPU resources. There's just a lot that you really need to get right to get it working. And overall, I would say the cost savings is probably trivial at the end of the day, unless you're working, and some of the Red Hat folks mentioned NFV. So unless you're working in an edge environment where space is very expensive, the one-time cost of purchasing a few more servers to run dedicated Ceph is going to significantly outweigh the advantages of going hyper-converged. RAID controllers is another tricky thing. If you're going to run them, just put battery backup units. Ceph assumes that when it writes to disks, things are written to disk for real, and RAID controllers can lie about that. So if you have a RAID controller with a bad battery or no battery that's doing write-back caching, you're probably going to be in for a bad time if power goes out or something like that. Finally, don't overcomplicate and over-orchestrate your Ceph deployment. For example, OpenStack Helm allows you to deploy Ceph inside Kubernetes. I am terrified of that. I think Ceph needs to be as stable and as column of an environment it needs to be. It's also very easy to deploy, so there's not really a need for us to implement a lot of orchestration tooling and all of that. It's just, make it simple binaries, simple packages, get it up and running. And then finally, is don't cheap out on hardware. I know we all, see Ceph as a great thing to run inside of a white box environment, and you don't have to buy expensive appliances from vendors and whatnot. But the difference in cost, take some of that and put it towards really reliable hardware. Because one of the things that Ceph is great at is doing what it does, but one of the things that it can struggle as is if the underlying infrastructure is problematic, if your network is weirdly dropping things, if you're getting weird disconnects across the network, if your systems are running out of resources. Those are the things that can introduce edge cases, and then you don't really want to have issues with your Ceph because it's really going to probably be at the heart of your entire cloud deployment, and any Ceph issues is going to result in a widespread outage, and nobody wants to deal with that. So those are some of the things that I wanted to just share about what to do and what not to do, and I guess I'll hand it over to Kendall to.
Yeah. So you talked a lot about things to consider when deploying your clusters and getting your cloud set up. And you definitely have a lot of experience with all the different deployment tools, having been PTL of 2 of the different projects and being involved in OpenStack Helm now. So which one would you recommend, I guess, for like first-time deployers?
Mm-hmm. So I think, they're all pretty good. The only one that I would rule out, and I think it's a great project, it's not kind of like, I don't think it's not good, but Puppet OpenStack is designed for purely like simple modules. It's kind of like you have to go and tape them all together. OpenStack Ansible and OpenStack Helm is a bit more integrated, where you can just kind of go ahead and deploy, and TripleO as well. So your options, if you want to get something like a single node that's pretty close, I would look at PackStack, which is an interesting option that's provided by the RDO community. That'll get you something inside of a CentOS system very easily. And DevStack is also an option. Those are in my opinion, the best one server tooling. And then anything that goes a little bit beyond that, I would suggest, seeing what works best for you between TripleO, OpenStack Helm, and OpenStack Ansible. Those are all very solid community-based options. Sorry, and Cola Ansible. That's something that I haven't interacted with that much, but I know a lot of individuals that deploy using it.
Yeah, I have definitely heard of a lot of good work being done, especially in the last couple of releases on Cola Ansible. It's definitely been one of the larger growing in popularity deployment tool options. So if we could bring everybody back on, we have a lot of questions from the audience, but unfortunately we're running out of time, so we'll try to get through a couple of them quick. So earlier in the show, there was one from Danny on YouTube. It was why Ganesha into OpenShift as opposed to, say, RBD or straight CephFS. I think, Tom, maybe you're probably best poised to answer that one since you were talking about that. But if anyone else has an opinion, feel free.
RBD. And they're basically, you want to be able, RBD's block and Ganesha is providing file. So they're very different use cases. We briefly talked about the fact that when you write from multiple nodes, we're talking about it in the Kubernetes context, but it also applies just to VMs. When you write from multiple nodes, if you have a node local file system on your block device, it's not going to work out well. You need a shared file system or a clustered file system. That's basically the reason why file system, and Ganesha is one example of file system, would work there. The other case was native CephFS versus Ganesha in the question. And there it all comes down to whether your users, your tenants, in general sense of that word, are case of a public cloud, case of large enterprises. Many cases, your public, your general users need to be able to use stuff but are not trusted to access the cloud infrastructure. With the native CephFS, you run a CephFS client in a VM that a guest owns, and there's cooperation required between client and server. If the client isn't keeping this, if the user isn't keeping the software up to date with CVEs, you might get in trouble. Quota enforcement depends on clients, et cetera, et cetera. So you really only want to use native CephFS when you know, for example, if you're deploying, if you're a cloud administrator deploying your own public Kubernetes service on your own VMs, then yeah, use native CephFS. You know, you are trusted. You're yourself. It's the clearest. But in the case of to the other extreme, a public cloud where somebody gave you your credit card and you don't know whether they're running Windows or BSD or an old Linux of some sort or whatever, you don't know what kind of Ceph client's running there. You don't know if the kernel's been hacked, et cetera. So an NFS gateway is one way to protect that. I'll put in a plug for PTG. We're also working on BirdIOFS as another way to protect untrusted VMs and keep them from direct access to the Ceph public network. Yeah,
security is always a thing to keep in mind when making decisions on how you're gonna set something up and deploy it. So we have another question from YouTube. YouTube's a popular place today. From Vlad. Any tips to lower latency on all-flash Ceph for read operations? What are the main things to look at?
We run NVMEs across all of our stuff. We recently finished switching to everything. One of the things that I would suggest looking at is if you have the latest release of Ceph, they recently introduced a feature which is a read cache that runs on the hypervisor. Like could run on the hypervisor itself, right? So whenever you're doing reads, it could actually cache the data locally. So the next time that you do the read, it's actually reading it from the local system. So you can designate a hard drive on that same local system that's going to be caching reads so that the reads are coming faster and don't have to go across the network. That's going to help reduce latency for reads. But you know, that's kind of one of the things that I might throw out as an idea.
Awesome. Anybody else have?
I don't know if he's using, if you're using multiple OSDs per NVMe, you can. There's a nice graph on how you can just get more and more performance out of your NVMe by having multiple OSDs on them. And of course, there's Blue Store, and then C Store is coming out, which will use the NVMEs even better or more efficiently.
Cool. Well, one last question before we wrap up here. There are so many good ones from the audience. I really wish we could get to them all, but generally, why are OpenStack and Ceph such a good combo? I'm sure everybody could come up with an opinion on this.
Well, I get excited about it, but I mean, it's kind of like OpenStack here, commodity hardware, build your cloud. And you're like, okay, cool. You know, the virtualization is there, but what about the storage? Well, you know, we have a lot of the storage tools in OpenStack are all provide interfaces to get to your storage. But what do you want to actually use to provide your storage? What is the commodity hardware solution to this? And that's Ceph. So that's where it fits so naturally. It's the open source way to take commodity hardware and make a great storage cluster out of it.
Yeah, I agree a lot with that as well, because when you think at all the other options, I think the biggest thing that draws to Ceph is the availability features. So, I mean, if you use something like LVM through Cinder, I mean, great, it does the job, but if that node goes down, everything goes out. And Ceph is kind of like a really, really intelligent system that does all of that for you. And as well, it's probably, it's the most popular and like I said, use the most tested code bases. So most people are running block storage with Cinder. You're probably going to have a really good experience using Ceph, and there's a reason everybody is using it.
Totally.
And the integration, I guess, on the tool with Ansible on everything else is quite well done also. So it's quite really easy to integrate Ceph with OpenStack because it's just open source, and all the other open source tools like Ansible and everything, it's just well implemented all together. So that's make a great point to use.
Open source communities coming together is a beautiful thing. Building open infrastructure with project after project, and all of them are, supported by global communities. It's just my favorite part of my job. So we've covered a ton of ground today, everything from the basics of Ceph and how it integrates with OpenStack to large deployments globally with Societe Generale and VEXXHOST as well. So thank you all for joining us. I want to give a huge thanks to our awesome speakers. We really, really appreciate you taking the time to be here with me today. So a couple of things before we wrap up this week. If you're interested in getting involved or following the development of these integrations further, you can go directly to the Ceph documentation. We also have the OpenStack, or formerly OpenStack, now Open Infrastructure project team gathering happening October 18th through the 22nd, where we will have a lot of teams talking about these topics. So Manila, Swift, TripleO, and also Cinder will all be meeting throughout the week. And the OpenStack Technical Committee is also coordinating time at some point with the Kubernetes Steering Committee to talk about how our communities overlap and integrate. Quick shout out to all of our member companies, several of whom were represented here by speakers today, for making OpenInfra Live possible. If you're interested in joining the OpenInfra Foundation as a member, you can learn more at openinfra.dev/join. If you haven't already heard about the OpenInfra Live keynotes, those will be coming up November 17th and 18th. Join us for a 2-day special edition of this show. Not this one specifically on Ceph, but generally OpenInfra Live. And it'll be the best opportunity for the global community to get together this year and hear about all things related to OpenInfra. Registration is now live, so you can go sign up today and join us for those keynotes. Also, remember, if you have an idea for a future episode, we would love to hear from you. Go ahead and submit your ideas at ideas.openinfra.live. And lastly, we really hope that you are able to join us next Thursday for an episode covering what will be our 24th on-time release of OpenStack, the Xena release. So join us to hear all about what's coming and hear from the developers that made it happen right here next Thursday at 14 UTC. Thank you again for all of your wonderful input and information from today's guests, and we'll see you next week on OpenInfra Live.